So, hi, welcome everybody to my presentation with the title How to Survive the Last Slot of the First Day of the Presentation of the Conference. I'm Mahmoud. I'm the Information Security Officer at Autogroup DataWorks and a cloud engineer. And a little bit about me: I've studied physics, did my PhD there, university. Total have 10 years time at the university, switched over to IT consulting, mainly for cloud infrastructure and cloud migration, and switched over to Autogroup DataWorks during the Google Cloud migration, and there I'm full enthusiast for cloud security and with Google development, and also like to write articles about cloud security and these things in the blog post. So a little bit before I start, what is the Autogroup DataWorks? We are the holder of the Autogroup wide data pool with different brands from the Autogroup, on which we build data services, which we then provide back to subsidiaries, and have R&D initiatives like a chatbot, and also have a strategy and development department, and for example building currently a BI platform which has scale as a data source. And what is the data pool? It's based on our in-house developed Nitro tracking, which is implemented into many websites of the Autogroup. And with the Nitro we have this data pool and have a new achievement. Let's do that again. Have a new achievement that we now have to manage the information security for a data pool in a public cloud environment with many autonomous working product teams building products. And of course we faced challenges, and our engineering teams faced challenges, and some of them are for example that we encounter a high mean time to recovery during an incident, which is based on the fact that the threat landscape grows faster than the expertise of employees, and the security awareness is an infinite loop of educating people and also sustaining enough budget for security in an organization. Other challenges are that there is a trap or a common pitfall that the company has introduces many different security products, each which have to be learned by product teams, and each with their own unique use case. And of course there's an ever-present talent shortage, which makes the war of two speeds ever tight. And finally, there are, of course, in a cloud environment, complex environments, which manifests itself in that different solution built at different times look totally different because the technology landscapes move so fast. But most of the time, the security requirements stay the same. So product teams have to maintain security for different products they've built over time, and have this challenge. Together with the ladder of abstraction, which is a fancy word of saying there is now DevOps or DevSecOps, they wear a lot of hats and have to integrate everything into their daily routine, and with the common alert fatigue that which is actually a real stress problem for engineers from different products, and this becomes really present if by a recent vulnerability, namely Log4Shell. Who does not know about Log4Shell? Please raise your hand. So I'm not surprised that 99% did not raise a hand, but in general Log4Shell was one of the most critical vulnerabilities in the recent time, and it was based on a single Java dependency, Log4j, and was quickly adopted by attackers around the world during the Christmas season, so as an early Christmas present, but also led to a lot of work and overtime for security engineers around the world. And this makes the industry painfully aware that companies which adopt the public cloud environments are facing increasing security challenges in their digital supply chain. And the reason for this is that modern software supply chains are complex, and they are built, or they're composed of many building blocks from different cloud vendors, each cloud vendor with their own security product, which covers only a part of the supply chain, but not a holistic view across the whole supply chain, where at every link of the supply chain a vulnerability can occur. And Log4j was only an example for that. And such a vulnerability can easily lead to a data breach. The Verizon data breach report just recently was published, which showed us in average for an organization, a data breach costs several $1 million. But even without paying for a data breach, for example, for ransom, companies have to pay money and time for the handling of a security incident, because normally security incident or many security incident is managed by engineers, and this leads that projects get postponed and precious engineering capacity gets drained by a security incident. And the reason for this is that manual processes because of missing data. A typical example is in the corporate environment, the CISO initiates a security incident to the information security officer of a company. The ISO forwards it to the product owner because it does not have a clue, because it needs the information about the affected systems. The product owner forwards it to the engineers. The engineers talk to each other because they have to find if they're affected and which system they're affected. And the way back, it's all Excel, the way back. And the ISO then reports back to the CISO, and the threat landscape changes, and everything has to be done again. And this takes time and sinks a lot of effort. And the reason, this is the reason why we have built Pantheon. Pantheon is a solution, and it's a central portal which enables companies to incorporate security orchestration into a digital supply chain and to ensure the security status of their cloud environment. And the main things I want to next focus is security orchestration and digital supply chain. These are the main points. And then we dig deeper into what is this solution. So what is security orchestration? It is based on 4 key aspects in our view. So the first thing, it is multi-enabled from the get-go. So it integrates with multiple cloud vendors across the supply chain and supports the cloud APIs. Additionally, it has a low detection time, means it has real-time capability, and it has a high coverage in every link of the supply chain. So for example, any dependency will be covered, and not only a surface will be scratched. And finally, it can be used for anomaly detection to identify suspicious changes inside the supply chain. And we did this with Pantheon, and we do this by actually just harvesting real-time data using cloud APIs from different cloud providers using our graph algorithm. Then we unify this data into a unified data model, and with each, based on this model, we perform security analysis to identify suspicious vulnerabilities, and then we notify back and record the non-compliant resources. And we do this across the whole supply chain of different cloud providers. So now we can answer typical questions in such a setup of an organization, for example, being in the public cloud and building products, or product teams building products. And for example, the first question is, which product teams need some more security support? Which is very important for me to see where to start. And for this, Pantheon provides a security score, which is a aggregation, a scoring for projects to see how they are ranked to each other and which one is the lowest. And we provide this via the dashboard back to the product teams, and also measure it over time to see historical data. Another question we can ask is, how's the current security posture as a whole? For this, we have built on top of our platform a continuous compliance testing, which means that product teams can have an overview how they are scored across 12 dimensions, and what is the call to action, for example, which they need to have work to do. And finally, to also attack the alert fatigue, is we can ensure high alert fidelity by incorporating justification rules for product teams to say this security rules or this vulnerability or this issue is actually justifiable. We need that for our production system, and they can do this with regular expressions and with rule matching. And this just wipes away a lot of classes of vulnerabilities or issues, sorry. To see that in action, I have a pre-recorded demo. And because I didn't know it, I thought Keynote 2 was really big, that everything is so brought up. But I hope you in the first line can see the demo. So how does this look under the hood? So it's a small interlude about the engine, because we need to go deeper for this. And why do we actually in the end build a security product? And the reason for this is that we have 3 or 4 years ago published our security framework, how we want to have, what is the requirements for a security monitoring solution. And it's based on 5 pillars, and the most important one, the bottom one, is the detection layer. To have the transparency on a cloud environment. And we deeply believe that if you only know your assets, if you have the transparency of your cloud environment, you can only then build a secure environment. And because we are in the Google Cloud, we see what Google Cloud has an asset inventory, and we ask, yeah, it's complete, right? But what we noticed that it's actually not that complete. So we ended up being here again, which put us on the road to scrape all GCP APIs. But our road started, of course, with the first step here, and we thought, how should we go back this road? And just realized or have the idea that we can use the same functionality GCP uses to create this client for Go client or Java clients using the Discovery API. So Discovery API is a service Google provides, which is basically a meta API describing all other APIs. So it's a source of truth about all the APIs, which we can then scrape. We use this to build a graph meta model. So we have built an understanding of all APIs, how they're linked together, and in which version they can be put together. And after building this graph model, which was a master thesis, we then generate a lot of code. After generating this code, we put this into a runtime, which is a cloud function, and we're able to meet our objective to have all the GCP assets. And this graph API is a text representation, and only using the cloud asset inventory, it looks like this, that it defines that there is an API method producing a certain resource, and only using the cloud asset inventory, we have 250 assets coverage, which is the amount you can cover from your cloud, from your supply chain. But with Pantheon, we currently have over 700 assets, ever growing, because GCP produces new GCP APIs. They get be published, they get be generated, and it's automatically updated. And for the engineers in the room, the actual graph looks like this. It was a dump from yesterday, and if we have a zoom in, it looks like this. So it has an understanding how resources are linked together, And especially for the case of buckets, which are cloud storage buckets, it even understands that actually cloud storage has two different access modes. One is bucket access control, which is a legacy access control based model, and a policy, which is an IAM based model. And it has this understanding, and thus you can scrape very efficiently the cloud. For this, it needs a cloud architecture, which looks like this. And this cloud architecture maybe looks a little bit fancy. The most important thing is that great red arrow, because what it shows is that it just traverses this graph and actually puts an avalanche of tasks into the task queue and just scrapes away. Just you can imagine it's being a fancy web scraper just for the cloud. And what we get by this is now full cloud transparency. And what we do with this, actually Pantheon is now for us a technical data warehouse with a lot of metadata, and we use it as a source of truth for our security. We implemented over 130 security checks, the 12 compliance controls. You see all the public benchmarks, or the popular public benchmarks are included. And we use this for our incident response. So this is a concept screen, but in general it looks like this, that if you want to see, for example, in Log4j, if you're affected, you just perform, say, SQL query against a database. You can ensure that it's live data. You can query it. Where is the vulnerability? Who is the owner of it? Is this vulnerability deployed? Where is it deployed? Is it exposed or not? And then just create a report or whatever. And with this, we can at least, for some of the challenges, be a little bit, have a checkbox, or be sure that we have it covered. So with this, thank you for your attention. This was a presentation, and of course we are hiring, and we are still at the booth. So if you want to talk, just answer now or meet me there later.